In my another kinematics tutorial. This is I am going to solve from Cambridge Admit book, question number 8. In this time it's a board exam question. The paper number is 606 and March 16 question paper. It is written here, a particle be projected from O so that it moves in a straight line at time t seconds after projection. The velocity of the particle v meter per second is given by velocity expression is given here. And first question asking that show that p first comes instantaneous rest when t equals to 2. How would you understand that at the time t equals to 2 it comes to rest? After putting this value t in the expression of the velocity, if we found that velocity becomes 0, then we can say it comes to rest at that point t equals to 2. Let me do that. Let me check. We are going to put t equals to 2. Then velocity, what is the velocity? Let me find out the velocity. 2 square minus 63 into 2 plus 90. We can use calculator to do that. 4 9 is 36. Then minus 126, 126 plus 90, and 90 plus 36 is 126 minus 126, which we got from there 0. So it shows that at that time t equals to 2 velocity becomes 0, and that point it is called the rest. At rest actually velocity becomes 0. So it is asking you show, so you can write here shown. That is the working of the first question. The second question written here, find the acceleration of p when t equals to 3.5. From velocity we first find out the expression for acceleration. We need to differentiate the velocity expression d by dt of the velocity, and velocity written here 90 square minus 63t plus 90. If we differentiate, we know it's a simple differentiation. 9 to the 18t minus 63, and 90 becomes 0. It's a constant. So this is the expression for the acceleration. Find then it is written here, find acceleration when t equals to 2. So let me write here, when t equals to 3.5, question is asking us to find out the acceleration. So we are putting the value of t in the acceleration expression, 3.5 minus 63. So we also can do that one by using a calculator. Let me see the calculator. We can put the values in our calculator, which 18 into 3.5, 18 into 3.5, then the another value is minus 63, and it gives us 0 again. So at the time t equals to 3.5 we got the acceleration 0, and this is our answer. Next, move to the next question, part 3. It is written here, find an expression for the displacement of p from O at time t seconds. To get the displacement from velocity we needed to integrate. So let me do the integrate. I'm going to change my color with the red color, integrate, and we can write expression for displacement by x. Let you write it, and in this time we are doing integration 63t. While you are doing the kinematics question, you must need to know all the differentiation and integration part to do the maths quickly. So integration is 9t to the power 3. This is the basic integration. Then minus 63 t square divided by 2 plus 90t plus c. This is the expression of x. We now have to find out the value of c from here. We are going to write that expression in simpler form, which gives us, we can cut out 3, it becomes 3t to the power 3 minus 63 by 2 t square, then plus 90 t plus c. To get our value of c from here. In this question it is written here, at time t seconds after projection and from the origin, so it moves in a straight line after projection the velocity. It implies that at the moment, starting moment, when t equals to 0, its displacement is also 0. So we are going to put there when t equals to 0, its x value is also 0. And then if we put in this equation x equals to this one, then definitely we would get from there c also 0. So now we can write our final expression for the displacement, which is x equals to 3t square 3t cube, which is 3t cube minus 63 by 2 t square 63 by 2 t square plus 90t. This is our expression for the displacement. We have done till to 3. Hope the way I'm solving the question you would understand from there. It's a question from exercise 16.3. Is from the Cambridge Admit book. In this time we're doing the question number 8, and it's a board exam question. So let's move to the next part of this question. We are doing the question number 8, and another part of this question, it is written there, question number 4, find the distance traveled by p, and it is given there in the first 2 seconds. How to do that? We already have our expression for displacement, which is from 0 to 2. Distance in the first 2 seconds, we have the displacement expression. Just we can put the value directly at the moment it passes at 2 second displacement and 0 second displacement. Then we can find out the final answer. Because its velocity, we got the first question answer at the moment t equals to 2, then velocity becomes 0. So directly we can put the value, no problem. So let you do that. Displacement we are going to put, because we already have done our integration, which is 3t cube minus 63 by 2 t square, then plus 90t, and we are going to put the limit from 2 to 0. So let we put the value 2 to the power cube minus 63 by 2 square plus 90 into 2. And if we put 0 also, minus 0 we can write. So let's see what is the value coming out from there. We can use calculator again to do that. Let you write 3 into 2 cube is 8, then minus 63 by 2, minus 63 divided by 2, and then next value is into 2 square, we can write into 4, then plus 90 into 2. So finally we got from here 78. This is 78 meter is our answer for this question. Now the last question in the first 3 seconds. So we cannot go through now directly from 0 to 3 seconds, because reason behind it, at the moment t equals to 2, it turns, because velocity becomes 0 at the point rest. So if I draw a diagram, I think it would be clear with you. So say it's like this. So at the moment t equals to 0 is here, and at the moment when it is turning, then it is the value t equals to 2, and say this is the value when t equals to 3. So we know this is the distance from here to there is 78, and we have to add this value as well. So let you find out, because it is going back, so it would come the negative value. So the first one, from we are going to find out the expression, we are putting the limit in the expression of displacement from 0 to 2. This is the positive value, and another limit we have to put for x, which is from 2 to 3, and 2 to 3, because it's the opposite direction, so it would come negative value. So we need to make it positive from there. So from the first part we got the 78, and the second part of this value, let me see what is the value coming out, because we know if we put there 3, then it would value 78, and instead of 2, 3, if we put that to, what is the value coming out? Let me check with the calculator, which we can write 3 into 3 to the power 78 2 to 3. If we put that here, oh, extremely sorry, I needed to first put the 3. So 3 into 23, I mean 3 cube. Let me see, because we have the value after putting the 2. So 3 into 3 cube, then another value is minus 63 by 2, minus 63 divided by 2 into 3 square means 9, you can write, plus another value 90 into 3. Let's see what is the value comes out, which is, we can write 67.5. so it's not 78. If we put here 3, then we would get from there 67.5. let me write here 67.5, and if we put 2, then it definitely would be 78. See, this is the value negative, so we need to make it positive, then we can add with that one. So plus, what is the value coming out? 67.5 minus, if we write there 78, then it value comes out from there, which is 10.5. so we are going to add by making it positive 10.5. so our final answer is 88.5 meter. Hope you understood the way I did the question. This is the AdMath book last question number 8 from Cambridge. If you are new in my tutorial, you may subscribe if my tutorial gives any value to you. Thanks for watching.